Uh, those are just the kinds of things I do when it's 4:43 on a Friday. And we've been learning all week. It's crazy. Have you ever lived life this way? Like, has this ever been your life before? It's crazy. It's just insane. So much learning and so fast. And it's scary. But like, third grade wasn't this way. I know you've been in a like 8.5 hour day school environment before, but come on. Like, high school wasn't like this. It just wasn't like this. And then college, maybe the curriculum was as intense at times, but you didn't do it like a full-time job. So I understand the feeling of 4:44 on a Friday night at Full Stack. I understand. That's why I'm going to be keeping this lecture extremely to the point. There is a lot of theory behind what we're going to learn. There's a lot of things we can talk about as far as how to categorize databases and the needs for tools like we're going to learn in ORM. We have resources to show you that, and I'm going to be sharing that with you after the fact. But I don't think that this group can handle, at 4:44 on a Friday night, a whole bunch of theory. So what we're going to do is we're going to look at Sequelize in the way that we're going to see how awesome it is for interacting with databases. Let's skip the theory for the time being, and let's just see how to use this tool and what it can do and why we're learning it. And by the way, Sequelize is part of the 4 pillars, as I always call them. The 4 pillars of what you learn here at Full Stack, which is async and promises. You finally got to see what those were like. And those are very convoluted and can be very, very hard to wrap your head around. But it's OK, because there's going to be another promises workshop just about promises. And they're going to pop up over and over again. In fact, that's why we have to do promises before Sequelize, because Sequelize uses promises by default. The other 3 pillars are Express, React, Sequelize. This is one of the big things you need to know. Really, really big things. So what is Sequelize? Sequelize is known as an object relational mapper, or an ORM. If you have come from maybe some previous experience in software, probably like Java or other web application languages that are a little bit more domain heavy, like Ruby and PHP, you may have run into one of these tools before. Active Record, Eloquent, I forget Java's, I forget what it's called. And there's obviously a few. But what it essentially allows you to do is it allows for you to interact with SQL databases through object-oriented constructs from your language. So you essentially have this translation. I'll go back to this slide to talk about some smaller features. But you essentially have this translation that takes place where what you think about in Postgres as a table, you think about via Sequelize as a model or a class. And what you think about as a row in those tables in Postgres, in your database, you think about them as instances or essentially things that you construct out of your classes. Sort of like what you learned, how you learned it in Foundations. You learned about classes. You learned about using classes with the new keyword. It doesn't work exactly the same way in Sequelize. We don't use the new keyword. But it's the same idea. You have a model, which is like a tool set, and it represents the whole table. And then you have instances of the model, which represent row by row. And using Sequelize, we have a whole bunch of different things we can do to bake into our Node.js programs, which can also include Express servers, which can interact with Sequelize. But we can model our schemas and provide validation for our schemas through Sequelize, meaning that what? What does that mean? We can model our schemas and provide validation.
Something like you will declare objects and it will translate them and validate that they can be done in a database.
And not only that, it'll go and create tables based on that definition. So essentially, so question for you, How have you been creating tables in your databases in the workshops before right now? Create table statements directly into SQL, right? For Twitter SQL, you had to go into pSQL and then run a create table command. And you copied and pasted from the workshop. For the IMDb workshop, they were already sort of there, but you could do .schema and see the tables. The idea here is that you can define what your tables should look like via your JavaScript node application using an object, a JavaScript object, to say this table should have this name, it should have these properties, these columns essentially, and each of these columns should be controlled by this validation. Can't be null, has to be an integer, can only be this long, can't go below or above this number. And you can do all of this through Sequelize. You also have this aspect of data casting. So there are certain types in SQL that aren't the same things you use in JavaScript. For example, the way that you put a date into SQL, there is a very, very specific construct and format that you have to use. Is everyone aware of the date object in JavaScript? So there's a translation that Sequelize does there. If you have a record in your database that has a date field, and it is formatted in this way that Postgres formats dates, Sequelize, when it reads that record, translates that date into a JavaScript date object that you should be more familiar on how to work with that. So it essentially represents the data in your database in JavaScript ways. It allows for you to build queries. So rather than you writing SQL, which is the biggest obvious takeaway from Sequelize, you don't write SQL anymore. You have the option to write SQL. Sequelize has a raw method where you can just provide a SQL string and run and I've used that actually in the past out of necessity. Because sometimes query building in Sequelize reaches its theoretical limit of how it can do something, and if you get into a very complex situation, sometimes it's better to write a raw SQL query. But I've only had to do that once in 6 applications I've built with Sequelize at this point that were all fairly big. So Sequelize allows you to do the most basic things and then even some advanced queries just by calling JavaScript methods and writing no SQL whatsoever. You can also do certain things like provide hooks. So hooks are essentially operations that take place during the life cycle of rows. So you can imagine if a row is going to get deleted, you can register a function that should run because a row is being deleted. Or a row is about to be created. You can supply a function that should run because that row is being created. So remember we were talking about that ranking issue during the schema design Hogwarts thing, where each team had a rank? And we had this idea of okay, if we give this team points, they might become a new rank. So we'd have to go and visit all the other rows that are below this rank and adjust them. This is something that if we had to do that, we could do pretty easily with a hook, because we could say, before this row updates, let's go and check its current point value and then update all the other rows in turn. And something that we can just sort of register as an automatic response to certain actions. And you'll learn about these during the workshop. We can have class and instance methods, which means that we can essentially provide customized utility functions for either one, the model itself, so things that basically custom query functions, so we don't have to write the same advanced query over and over and over and over. We can centralize that. Or instance methods, where we can say, if we have a row, we can do some predefined operation on that row based on a function. We'll get into those. And then getters, setters, and virtual fields, which I think without us seeing it Sequelize up to this point will be too confusing to talk about, but we will get to. So the basics of Sequelize is you make a model. Remember, a model is like a representation of a table in your database. You can extend that model with hooks and other utilities, class methods, instance methods. You take the model and its definition, how you defined what that table should look like via the model, and you sync it to the database. And what that's going to do is it's going to create the table in your database, And then you can use that model to create and find rows and edit them and delete them. So, okay. We'll go back to this slide after we see what that actually means. And that actually like involves some setup as well. So is anybody already using Postigo? Anybody already download Postigo? If you have not downloaded Postigo yet, Postigo, I highly recommend you downloading Postigo because there are some full stack students that I am sure are very big fans of the movie The Matrix that love interacting with their Postgres database through pSQL. They just like want to stick to the terminal as much as possible because they think it's awesome. It's just really not workable most of the time. Postigo is a really important tool for you to have because it just allows you to visualize what's in a database at any given time through something that is like reasonable, I would say. Charlie. It is, yes, I suggest, if I were to suggest Postigo to a DBA, they would laugh in my face. Yeah, because it is very simple. Like there's a very, very limited amount of things you can do with Postigo, whereas pgadmin is far more broad in its functionality. But that also means that for very simple things, like just I want to go look at my rows, you have to go into these like nested meta tables, yeah? So yes, I would absolutely 100%, if you're on a Mac, I'm sorry, I would suggest Postigo over anything else that I've explored. I can ask some people in senior cohorts and the fellows and instructors that use Ubuntu what they suggest for a GUI for people who are on Linux as well. I just don't know off the top of my head. Postigo? You go to you Google Postigo, you download it, you install it. It really is just like that simple. And then you just have to set up the connection, and that is localhost 5432. So if I were to quit Postigo and go here, you just have to like, you also don't have to pay for it. It doesn't really like, you just have to like create your connection. In this case, I have localhost 5432. The user usually doesn't matter. And then you just have that and you connect. But it's pretty intuitive. I think you'll figure it out. So keep in mind if you use something like Postigo, or if you use Postigo specifically, in this case, I am connecting to my database server, not any particular database. So the database that we're going to be working off of for this lecture doesn't actually exist yet. Doesn't exist yet. Not there. So I'm going to do that real quick. That's something that you cannot do with SQLize. SQLize expects that if you are going to connect to a database, that database itself already exists. So the database server, which is Postgres, I have all of these databases already created inside of my Postgres server. I'm just going to very quickly create a database. Does anybody know the easiest way to create a database in your Postgres? Assuming it's on. Yes, you can do that. Easiest, incorrect. When you install pSQL and the whole Postgres system, you get a convenient command line, like command, that you can just say create DB, and then I'm going to name this 1701 SQLize lecture. Okay? And then what this is going to do is it doesn't really give any output. But if you don't see any output, that's a good thing. Because now what we've done is, I'll just refresh here. I now have a database created that I can connect to with SQLize in order to add tables to, et cetera, et cetera. Wow. I am surprised by the confusion right now. Questions? Questions? What lost you? Yeah. In Postigo, yeah, you can add a database as well. Yeah, that is also very easy. Yes, yes, that is absolutely true. You can go to, yeah, it is easy, but where is it? Where do I have to look? I just have a search. Oh, file. Yeah, this seems pretty hard compared to what I just did. Right click here. Do I go to maintenance vacuum? Do I go to vacuum? I don't know what the hell that means. There are a million ways to skin an animal or whatever. I don't know. That's a really weird phrase. My preferred way to skin is create DB in the terminal, which you should all be able to do. But yeah, you could probably create through PostGo as well. Jacqueline? Well, there is no existing backend yet, but there will be soon, my node process. When we're thinking about Postgres, Postgres is like a server. Postgres is like a process, like a node process. It isn't written in Node, but it's like a node process that's just running on the network on a computer. And it just happens to be, in this case, on the same computer that my node process is going to be on as well. But it could very easily be on another computer at another IP address running on a specific port. TCP is already being used even if it's on localhost. You can imagine that the signal and the connection is happening from one side of the computer to the next, but you can extrapolate it very easily to it being very, very far away. It actually works exactly the same. In fact, if one of you has your Postgres server on, your Postgres is open, and you see that elephant in the top right of your Mac, in the case of people who do have Macs, you could give me your 192.168.1.whatever IP address from the local network. I could connect to your Postgres database from here if you are opening up to all other remote IPs, and it would work exactly the same. Yeah. That's something that will become increasingly clear as we go forward, specifically when we're talking about deployment. OK, so I created a database. Now let me show you how to use SQLize. What we're going to do is we're going to be doing most of this lecture in a single file. And this is a bare directory right now. I have absolutely nothing going on in this directory, and I haven't done anything yet. So the very first thing that I usually do when I am building anything with Node is npm init y, just to create my package JSON. So if I install dependencies, they can be recorded there. And also, if I install dependencies, they'll actually go into a Node modules folder. So previously completely bare directory, now I have a package JSON. And the package JSON, just by saying npm init, looks like this. Takes the name of my directory that I'm in and then just like fills it in with the really default stuff. Okay? So in order to use SQLize with Postgres, you're going to have to install 3 libraries. Not just 1, but 3. We're going to install, as you might expect, SQLize, but then also one that you'll find familiar, PG, and then finally pghstore. SQLize is what we're going to be learning. And SQLize itself is not a tool to interact with databases only for Postgres. It also works for MySQL, SQLite, and MariaDB, and I'm assuming any others that third-party people have built plugins for, right? Probably, I guess. Maybe. The built-in dialects for SQLize are MySQL, Postgres, SQLite, and MariaDB. Those are the 4 databases you can use with SQLize. So if Postgres is supported by SQLize, which is this tool for you to interact with all these kinds of different databases, why did we have to install PG and pghstore? Ryan? Mm-hmm. Yeah, yeah. The idea here is that even though SQLize supports you interacting via SQLize with many databases, it doesn't want to install the drivers for all of those databases that you might possibly use, which are pretty large, just assuming you're going to use one of them. They assume you're going to use one of them, but they're not going to assume that you're going to use MySQL or Postgres or SQLite specifically. So part of setting up SQLize is you need to install the drivers for a particular database management system. So if we were using SQLize with MySQL, which is totally viable, and actually our code would look almost exactly identical because of how SQLize works, we would just have to install MySQL, whatever the package name on NPM for the MySQL driver is. Just something you have to install. And that's listed on the SQLize documentation. We are doing Postgres all the way through and staying consistent with that. So you have to install these 3 libraries. And because I did a --save, these go into my package JSON, and it lists out, if I share this with you, you can just npm install and get those 3 libraries. OK, now that I've installed these libraries, let's start writing some code. Now, I am not going to be building an Express server or anything like that. OK, that is something very, very important to understand about Node, is that it is not a platform for you to build servers with, although you can. But it's not limited to that. All my Node program is going to do is it's going to be something that interacts with my Postgres database. I don't need to build a server in order for that to happen. Did you build a server during Node Shell? You didn't even know what a server was, right? All you did was do fs commands based on the user giving you some stdin. So just keep that in mind. Node is not for building servers, but that is one of our major use cases for Node. In this case, I'm just going to be building a program that does some stuff with my database. So here's how to use SQLize. I'm going to require it in, first of all. Require in SQLize. Step 1, done. Easy. We're good. Step 2, we are going to use SQLize to set up a database connection. Usually this is just referenced as DB, but I'm going to say database connection. And what you do is you use SQLize as a constructor function. There are other ways of doing this, but this is the way I like to do it. You use SQLize as a constructor function, and you provide the location of where your database is. So in this case, I'm using the Postgres protocol. Imagine this is like HTTP : // This is Postgres : //. And then I'm going to say, where is my database located? Now, as I mentioned in response to Jacqueline's question, it could be on one of your computers. It could be across the internet in Norway. But in this case, it's where? Localhost, which is a nickname for what IP? Not 500. 127.0.0.1. To every Unix-based operating system, this IP means myself. It's a reserved IP address, and it means myself. And every operating system with this IP as myself typically nicknames it as localhost. So when you say localhost, you're really just providing a nickname. You're providing a variable, essentially, an alias for 127.0.0.1. So this is absolutely equivalent. And you can change, by the way, this nickname if you wanted to be whatever you want. So like, you could maybe make it like Pablo's house or something like that. That would be fine. We could do that if we wanted to. Probably shouldn't, because there's things that assume localhost. And then we're going to say what port. And we're going to say 5432. Because that is the default port in which the Postgres server runs on. This is like when you build an Express server and you say, run on this port, port 3001, port 1337, port 2005. It's arbitrary. It's just what Postgres installations typically run on by default. And in the case of mine, I kept it as the default. So port 5432. And then the last thing you need here is what? The name of the database that we want to connect to. So SQLize does not connect to the Postgres server as a whole. It connects to one specific database within that server. And in this case, I call this database 1701 SQLize lecture. 1701 SQLize lecture. OK? Does this make sense? OK, cool. Very similar to how you connected with PG. Pretty similar. OK. So now that I have this database connection, and now I do want to point out that on line 6, where I'm about to write some code, it doesn't mean that my connection is actually established or was successful. That's going to happen sometime later, and I'll remind you about that happening. It's just starting the connection at this point. It's starting to try to connect to Postgres right here. Now what we can do with Sequelize is let's just look back at that slide real quick. Let's go through some of its features. The most obvious feature, and the one that we're going to talk about now, is we can use Sequelize in order to define schemas for our database, which essentially means we can define tables through Sequelize in our JavaScript program, and then what should be available on those tables. So let's keep going with that team and player example that we talked about a lot the other day, just so that we don't have to ramp up to anything new, OK? So I want to create a teams table. So what I'm going to do is I'm going to say var team is equal to database connection dot define, and then provide the name of the table as a singular string. So define takes 3 arguments. We're only going to be talking about 2 for the time being. It takes the name of the table, or what you want the name of the table to be, as a singular noun, because it will pluralize it when it creates the table. And then, as a second argument, an object that is going to define the columns you'll find in that table. So what do we want for a team? We want a name. We want points, right? Remember we did some points. Let's just keep it to those 2, because it really, we can just keep it to those 2, and we'll learn a lot. So we can say, OK, a property on this object is going to be name. And then we can say that the type of this value in the database is going to be Sequelize.string. So this is something that you just kind of have to do with Sequelize in order to provide the data type of that column. Is they're all functions that are off of the Sequelize library. So you can't just put string here. And you can't just put like a string that says string or anything like that. You have to use the Sequelize functions that you receive. And this is something that you just sort of like muscle memory after a while when you're working with Sequelize. Yeah, there's a question? We are defining a table that's going to go into the database. Absolutely. Yep. And this table is going to be called teams.
And that object team will also be a model?
Uh-huh. Mm-hmm. Yeah. We are working up to that, sure. And then let's do one more other column, points. And points is going to be type Sequelize integer. OK? We can also, at this point, place some validations. Like, for example, allow null false. Does that make sense? Allow null false. What does that mean? It can't be null, right? If we try to create a record in the teams table, which is eventually going to exist, that has no name, then it will be invalid. We can also say that the default value for points is 0. So if we try to add a team to our database and we don't provide any points that they already have, it'll just start them at 0. OK? I know that like all of this is a lot of like new random syntax. It's stuff that you're going to get used to. The idea of Sequelize is what's important here. We have a JavaScript library that we are now using to create something for our database. We're defining a schema in our JavaScript application. OK, now that we have this team table, or this team model, what we can do is we can use a very, very important but sometimes hard to grasp method in Sequelize, but only after Rob's question. You mean the columns in the database? You mean like I haven't listed name and points? I mean, I've listed name and points, but I haven't listed an ID. It will have an ID. That is just the default. You can turn that off. But by default, if you create a table with SQLize, that table will have an ID column and will be a primary key. So if I were to run this node script, I'm going to go ahead and do that. I'm going to say node index.js. I'm just going to run this. OK, execute it. Something wrong, Dylan? No. OK. If I run this and I go and visit Postico, I'm going to go into the SQLize lecture database. I'm just going to spam refresh a couple times just to make sure it's synced to what's actually in the server. You'll notice that there is no table there yet. No table. There's no teams table. Just defining the model doesn't mean that the table gets created. The way you create a table is you use, off of the model that was created, so on line 6 we have var team here. So we use team and say sync. Now, this is, I feel like, an unfortunate name that they picked for this method, because it can get very confusing. Sync does not mean synchronous. It means synchronize. It means synchronize this model that we've defined in our JavaScript application with the database. And that will mean one of two things, depending on one condition. If this model represents a table that doesn't exist in the database, the table will be created based on the definition of this model. The other condition is this table will already be in the database, and SQLize will make sure that the definition that's in the JavaScript application matches what that table looks like right now. It won't change anything. It's just going to make sure that they match. Yes?
That's why when you sync your music with iTunes or something like that.
Exactly. Sync, in this case, means synchronize. Yes? What if they don't match? It depends on how you configure SQLize. If they don't match, it will sync fine, but then you'll try to use it and it'll break. You can also configure it to yell and throw an error saying that they're not matching up. It's a very uncommon scenario, though. OK, so now with this team sync method that I have here, I'm going to run this again. And before I scroll up in there and show you what happened, let's go to Postico. And you'll notice we have a teams table. So we use, I did not create this table in any other way any time before this point. We used a node program that has SQLize in it to create this teams table from scratch. And let's take a look at the teams table. It has 5 columns. ID, which somebody asked me about. Even though I didn't provide ID for this table, it created one. And it is a primary key, auto-incrementing. Name, points, and then 2 other columns, which I referenced a couple days ago. Created at and updated at. So that's something else that SQLize will do for us. Once we eventually, and we will soon, start adding records to this table, when we add them, timestamps are going to be created automatically for them to keep track of when those records were added for the first time and then when they were updated in the future. And the created and updated at will be the same time when you add it for the first time. When you access something in your JavaScript program that is external to the program itself, so I'm not talking about arrays, I'm not talking about objects, I'm not talking about variables. I'm talking about file system, I'm talking about HTTP requests, I'm talking about databases. Those operations that are external, that go to external resources, those operations are what? Asynchronous. Asynchronous, meaning that Node tries to compute as much as possible while those operations happen in the background. Which means that if I put a console log underneath line 17, that console log will be guaranteed to run long before my database is actually synchronized. So when we do an FS read file, when we did in Twitter SQL a dbclient.query, how did we know when that operation was done? FS read file, what gets the contents of the file? the continuation function or callback function, right? We say function error contents, or in the case of DB client query, function error result, right? We provide a function that is going to run sometime later when that operation is completed. That is the essence of asynchronicity. What did you just learn to make that a little bit more manageable? Promises. The reason why we do practical promises before Sequelize is out of pure necessity. Because with Sequelize, you cannot provide callback functions. And you don't want to. I know that promises are a new thing and they feel sort of scary. But I promise you that they are going to feel really nice once you get a handle on them. They're one of those things that's like super hard to get at first, but then once you get it, it's just magnificent. Like they're great to use. There's no recourse for you using callbacks, regular callbacks with Sequelize. Not anymore, at least. Yeah, they took it out. They were like, promises are way better, so we're just not even going to leave this in the code. So everything that you do in Sequelize, and this is a big thing. Like this is something that you should like write down in your brain right now, or if you have a laptop, you can write it down. Everything that you do in Sequelize that touches the database, that includes synchronizing your tables, that includes selecting, inserting, updating, deleting, anything that will touch your database and modify it in any way, it returns a promise. It returns a promise. So what does this do? Creates teams table in database. Or if teams table already exists, makes sure it matches. Does this operation interact with the database? So therefore, because we're using Sequelize, it returns promise. That's just a truth across the board. Yes?
That will synchronize only
Just the team table.
description of the table, not the instances?
No, there's no rows in play right now. Just the table, just a place for us to put rows, or instances, as you very correctly called them. So this returns a promise, which means that what we can do is, I mean, you could do syncing table, teams table. By the way, this is how I like to build variable names when I know that they're going to hold promises. I always write them as if they were pending. I always say syncing teams table, or reading file, or writing file, because it suggests that it's something that's happening and not something that's done. And then we can say syncing teams table, then does that make sense? Okay. Feel nice? And if something goes wrong with syncing the teams table, what can we do? Yeah, we can do some error catching. Catch, right? With Sequelize, it returns a promise, but there's one exception to that. Just doesn't a promise to you. You mean like this one? I'm not sure exactly what what you're talking about as far. Okay, so we have a connection being made, we have a model being defined, and then we have some syncing happening. So you're saying, is it conventional to put a console log in which one of those parts? Right. No, there's no convention. There's no convention for that because there's no information to be found at that point. The only point in which you know that your database connection is going to fail is once you try to do something with it. So in this case, once I try to sync my teams table based on my model, at that point, Sequelize is going to be like, I couldn't actually connect to that database. They do it so that you don't have to initialize asynchronously. So you don't have to create a connection and then work off of a promise and then move on from there. Why would you have to do that if you were maybe even possibly not going to even do anything with that connection? That's the idea. That's why we put a dot catch down here. This is very conventional. This is absolutely, I think you're obligated always to catch errors, no matter what. Anytime you're doing any kind of asynchronous operations, querying anything, even if it's the most simple thing of all time and you know there's no way it's going to go wrong, there is a way that it's going to go wrong, and you're not going to know and expect it. And then when it does go wrong, you're going to wonder, what's wrong? Because you're not catching the error. So you are absolutely obligated, and this is extremely conventional. And this, at this point is where we know that the connection would go bad. Let's move on to some other concepts. Sequelize lecture. OK, so we've defined a model, which is essentially a representation of a table. And we've done this completely through our JavaScript program running in Node using Sequelize. We've taken this model and synced it, synchronized it, with our database, which, because it interacts with the database, it is asynchronous. And because we're working with Sequelize, returns a promise. At this point here, we can essentially start using the model to do useful things. So here's one thing we can do with the model. We can add records. So using the model, which you can imagine is like, it represents a table, but it's also a tool set for creating and managing records or instances of that model in that table. We can say .create, and we can provide an object. So the name of this team is going to be Hufflepuff. And we are going to start Hufflepuff with 2 points because they're so nice. OK? So we are going to do team create. We are going to run that operation. And now let's run this program again. Something I didn't point out earlier, but did happen, is check out what's in our console. I'm sorry for those that can't really read it. Yeah, it's a SQL code. It's SQL commands. When you're using Sequelize, you're just using the layer above how a database works. You always got to remember that. When it comes down to it, whatever you're doing with Sequelize is going to bubble down into a SQL command that's going to run against the database. And in this case, when we did team create name Hufflepuff points to, what it became and what Sequelize actually ran against the database is insert into teams, ID name, points created at, updated at, values, default, Hufflepuff, to, timestamp, and then returning star as well in order to get that record back just when we inserted it. Capiche? Something to always remember, yeah.
You can also define any of the other 3 default values, like the ID, created at, or modify that?
Yes, you can. Yes, you can. Usually, you don't have that sort of like granular management of the timestamps because Sequelize is managing that for you pretty well. You could also provide the ID, but you usually just use auto-incrementing. This operation interacts with the database, right? It puts a record in the database. Let's prove that, by the way. I just want to go real quick. real quick. Just refresh this table, and you can see, hey, this record's in the database now. And this record's not in the database just for SQLize to interact with. This is the record's in the database for anything to interact with. In fact, Postico is interacting with it right now. Okay? It's just interacting with the database. It's not that like SQLize is now the gateway to this database. It's just one way that we add records and manage records in it. But not the only thing that can access it. Zoe? They are columns within the table. And the values of these columns are timestamps, date timestamps. You can turn these off if you'd like for any given model if you want to. You can configure it that way. I will also note at that point, SQLize is fairly massive in how it can be configured and used. And it's just going to take a while to like figure out the best ways to do it. The ways that we'll be showing you in workshops and reviews are what we think is the best. Most, easiest ways to go about it. OK, back to my question from before. Dan, yeah, you can ask your question. Yeah. Yeah, you're spot on. You're spot on. Returning star is a Postgres-specific SQL feature that essentially you can use with update and insert. No, just insert statements, right? And update. And say the row that you've inserted, make it the result of the operation itself. In other databases, it doesn't necessarily work that way. This is something that came up during Twitter SQL, right? In other databases, without using returning star, you'll insert something, but then you'll have to query for it right afterwards. There's also a way for you to get like the last insert ID and use that. Yeah, so you're a step ahead of me. So my question, we are interacting with the database with the .create. What does it return? Promise. Anything that you do in SQLize that interacts with the database returns a promise. So what we can do is we can say return team create from here, or we can just work directly off of it if we don't want to get into too many nested promises, callback, land concepts. What we can do is we can say, and maybe this makes it a little bit easier as well, creating a team. And that's going to be a promise. So it's something that's happening, but not necessarily done yet. And then we can say, we're creating a team, and then when that's done, we can go ahead and console log the team. And this is going to feel a little bit weird. We get this. This is what we get console logged. What is known as a SQLize instance. So the SQLize instance has this property called data values. And I'm just going to say this right now. Don't use this property. Don't use it. I know like the things that you want to get access to, like the name of the team and the points that the team has, seems to be located here. But really, you should just do your instance .name, .points. Even though when you console log, you're not going to be able to see those things, they are there. The data values is something that you shouldn't really touch unless you're in specific situations that we just don't know enough about SQLize yet to address. But this is a SQLize instance. This is like one of the shittiest parts about SQLize, in fact, is that when you console log something that you think is going to be simple, you actually have all this like information that seems pretty meta about the instance itself. Something that sort of gives me my bearings when I'm working with SQLize in this regard is you can always do team2JSON like this. And what that's going to do is it's going to turn it into just a regular JavaScript object with just the data about the row. So we can do that again, and you can see that it just looks like this now, which is nice, which is nice. So at the points in which you need to access properties, or you want to console log and just see the data values, you can do that. But you don't have to do it that often, because what we can do here is we can just say team.name, okay? And that'll work. You don't have to do team.datavalues.name. You don't have to do team.datavalues.id. You can just do the property you want, and it'll work. we get back Hufflepuff. Okay? Something to keep in mind. Sequelize is full of like these little snags, and I'm just trying to give you a heads up on them. Okay. What if I want to go and find, so something that's interesting at this point is I don't have any kind of like unique indexing on my teams table, so I just have 4 records that are Hufflepuff with points 2, just because I've run this node process 4 times with that create statement. So knowing that those are in there, what we can do is we can also use the model not only to insert records, but to retrieve records. So you can say find all, and this essentially is just select all from teams. And we have 4, length 4. So we do team find all, dot then, here's all our teams, which is an array of 4 sequelize instances. We can even say, let's go ahead and create another team, like create name Slytherin and points. Actually, let's not give them any points because it'll default to 0, right? That's how we set up our schema. And then, how heavy did we go into promise chaining? Should I do a dot then promise chain? Great, OK. So I'm going to say we're going to create that team first. And then after that team's been created, I'm just going to chain off of it here. So chain off of this promise real quick. My editor is being really funky right now with me. And this will be team Slytherin, a created row for it. But now at this point, we can do another select query. We can say team find one where ID or name is Slytherin. And what that's going to do is it's going to go and find the one team that's in my database. Or if there's many teams with the name Slytherin, the first team it finds with the name Slytherin. Which I already have on line 29, but I can go and re-access it. I could also do this with Hufflepuff or whatever I want. Or maybe I want to go ahead and find all teams where points is greater than 0. So all teams with points. Once again, I realize there's a lot of syntax that I'm just throwing out at you, but this is stuff that you just get used to. The idea is there. You're using a JavaScript library to query your database in ways that you're not actually writing SQL statements. Yeah? SQLized documentation is a funny thing because students usually hate it, but I think it's pretty OK. It's not written in the most friendly way, and it's actually split up into different parts. And that's something I do want to address to you separately once you've actually worked with it a little bit, is how to read the SQLized documentation. Because it is actually nice if you know how to navigate through it. But I would say that on a scale of 0, which is Socket.io's documentation, and 10, which is Redux's documentation, I would say it's at about a 6. Yeah. OK, 5. It's OK. It's good. It's good. You can find the things, but it's just it takes a little bit of experience in reading other bits of documentation to really understand this one. But these are the things that you can do. Here's what I want to show you next. I know that there's questions, but I do really want to get to these concepts. We can make another database table if we want to. We can say DB connection, define player. And now the player will have name. And we can say type sequelize string. We can say it has, what else do we have on a player? We can just keep it to name. Player doesn't have 2 points. Yeah, what team they're on. We're getting there. Yeah, age. Let's do age. That was there. You're right. OK, let's just keep it to that. So we have name and age for players. Now, in order to sync my player table now, I have to add another player.sync. And then those are going to be 2 promises that I have. And if I want to know when those 2 promises are going to complete, what can I use? Promise.all. There's an easier way to do this. here's an easy way to do this. If you have multiple models that are being defined to the same DB connection, you can just say DB connection synchronize. And what it'll do is it'll take all the models that you've been registering to this connection and sync all of them and create all those tables. So we're going to do this again, and I'm going to get rid of some of these contents here. Okay, and I am going to run this program, and it does some stuff. Looks like I still have that, but we now have a players table. Didn't have to create it through PostGo or pSQL or anything. I just wrote it in my JavaScript program with SQLize, ran the program. Now we have a table. Great. So now we can create players, whatever we want to do. But there's one very important thing I want to show you, which is, I would say this is one of the white whales of SQLize. It's one of those things that SQLize can be pretty massive and hard to understand, but you get used to it, especially the querying parts. But this part is a bit hard, and it takes people a while to get. But I'm going to try to give you a sort of an introduction to it. What haven't we talked about that is very, very, very important in SQL databases? Deleting. Deleting is really just table.destroy, and then you provide a where statement. Yeah, relationships, right? So something that Jess said earlier is that the player is missing its team, right? So if we stick with the assumption that players can only be on one team, that's what we're going to stick with for this introduction. Players can be on one team. If we're thinking about the database schema itself, what the tables look like, in order to say that a player is on a team, what should we do? Yeah, go ahead.
Add a foreign key that represents
To, right, take the players table and add a team ID foreign key that will reference a team that they're on. You can't do that through here. At least I don't think you can. You might be able to, but you don't do it through here. Not in the way that we're going to prescribe to you, in the easiest way that's possible. You don't put team ID here and then give it a type of foreign key and whatever, whatever, whatever. What you do instead is you define these two models in isolation without any relationships to each other. And then the models have relationship methods that you can call. Remember those names that I was giving to these relationships that I put in camel case the other day? Belongs to many, has one, and has many. Those are the 4 relationship methods you can call on models to relate them to each other. So let me show you what happens when I do this. Player belongs to team. What this is going to do is it's going to add automatically a column to the player table with a team ID column that is a foreign key to team. But that's not all it's going to do either. But let me show you how this changes the database structure. So now I go here, and you'll notice that player has team ID. Yeah, exactly. Where? It's not actually there. It's not there. That was a trick question. I lied to you. That's something that I do. It's one of those things I do in life. I lie. Why do you think? Let me just trust me that I did this correctly. I know I did this correctly. I'm very confident. What do you think went wrong? Pablo? I am syncing it. Yeah, I'm syncing. I'm syncing. Look at the comment. That should be your hint. The player table was already there because I synced it earlier, right? So what SQLize does is it doesn't take the new definition of any model, which now includes this relationship between those two models, and overwrite the tables that are there. It'll just see if they match. And in this case, they don't match. And we're not getting any error about it, but it doesn't try to create a new table with this new definition or structure. Just to prove this point, I'm going to add something. I'm going to make an arbitrary column on my player table, and I'm going to say the type of my arbitrary column is a SQLize date type. Okay? And now I'm going to run this. It's going to sync to the database. And I should clearly have an arbitrary column, but I don't. So if tables exist in your database already that are going to be created by those models, they don't get overwritten unless you do this. You can configure your synchronize method to be force true. If you say force true for your synchronize, what this is going to do is it not only is going to take the models and attempt to put them in your database, it is going to put them in your database. In fact, it's going to go to all the tables that exist for those models that already are there, drop them, and get rid of their data completely, absolutely wipe their existence from the face of the earth, and then recreate them depending on the model definition. So by doing this, now keep in mind, if we go to Teams, we have a whole bunch of data in here. That's something that's important to point out. I'm actually going to get rid of this team create as well. Okay, there's a bunch of data in here. I'm going to run this program again. It's going to do a force sync on my database. And now you'll notice that 1, players is updated, and we'll get to that in a second. But 2, my teams table is empty. Because what synchronize force true did is it took the teams table that was there, got rid of it completely, and then recreated it based on my model definition. That force sync true is actually something that comes up a lot in these workshops and just generally, because it's about the initialization of your database through these models. So force true means get rid of everything in the database and recreate it based on these definitions. If you don't use force true, it's a little bit more conditional. If it's already there, don't do anything. If it isn't there, create the table. Does that make sense? OK. Yes?
If you don't want to lose the data, would you have to create another table copy and then recreate it?
If you don't want to lose the data, now you have yourself in a situation that requires a lot more care. If you're in development, your data should never be considered crucial to the point where it can't go away for arbitrary reasons. You should always be able to recreate it fairly quickly, and that's usually through a seed file. But if you're in production, yeah, this is a big thing. This is a very, very important thing. Keep in mind. And you'll learn those tactics in time. So now we have 2 tables, and let me show you the effect of our relationship. We now have a column in our players table called team ID, camel cased. And now we can essentially say these players are in teams. But not only can we create players on teams, so let's just do this. We're going to say team create, name, Gryffindor. I don't know how to spell Gryffindor off the top of my head, so we'll just do Hufflepuff again. And then this team is created, team. And we could say, OK, let's also do a player create. This isn't how you should be writing promises, by the way. You should be doing this a little bit better. You should be chaining them and returning. But I'm just keeping it simple for now. Player create, and then we're going to say the name of this player is, of course, Harry Potter, although he is not a Hufflepuff. I can't think of a Hufflepuff. This is the problem with Hufflepuffs. Neville. Neville's a Hufflepuff. Neville's Gryffindor. You liars. OK, it doesn't matter. Doesn't matter. Doesn't matter. Who cares? Age 13. He was 13 at some point. And what we're going to do is we're going to say his team ID is equal to team ID. So the team that was created by this, which we're doing a dot then for, we're going to set that ID. So that's one way that we can do this. So now if we run this, we can see that Harry Potter is now on team ID 1, and team ID 1 is Hufflepuff. Okay? There's other ways we can do this. Keep in mind that I have my force true set here. That means every time I'm running my program, it's wiping the database. Okay? Just something to keep in mind. So my data's starting fresh. What I could do instead of this as well is I can say, let's create the player, dot then created player, and then I can say created player set team to be team. So not only does this change your database structure, it actually gives you a number of methods to be found on the instances of your models. So in this case, the players. In this case, anytime you have access to a specific player, like Harry Potter, like who I created down here, this created player, I can do things like this. Set team, which allows for me to assign the team. This returns a promise because it interacts with the database to set the team ID on the player. I can also say get team. So if I have access to the player but I don't know their team, this will go and retrieve the team based on the ID that's attached to them. I can also say, I think that's the only two things with belongs to that I can do. Oh, I can also do a player create team. So this is the case in which you want to create a team and associate it with this player at the same time. But this is the stuff that Sequelize gives you through your associations. And this can go really much deeper. But if you do these associations, your instances, the specific rows that you get access to in your program can now do these things a little bit more granularly, managing these relationships. And you'll rediscover and come back to all this stuff a lot. So we have 10 minutes until party time. Does anybody have any questions? The things I will say before those questions come is there's a lot to know about Sequelize. Something that we didn't go through is hooks, class methods, instance methods, and you're going to be doing all these things in the workshop. And Sequelize itself as a tool is massive, and there's lots of different things to do stuff. You have to be patient with yourself in knowing all of those things and how those things are useful, because there's just a lot going on. Sequelize also is just going to stick around for the rest of the curriculum. And you're going to be using it a lot, and you're going to be learning things about it all the time. A lot of people learn the most about Sequelize, in fact, during their first senior phase project. That's like when the Sequelize learning goes from like beginner intermediate to almost advanced. And yeah, the general idea of it is that now we have a JavaScript library that allows for us to think of our tables as classes with these methods on it, and to manage our database in object-oriented ways, programmatic ways, as opposed to SQL statements. Pablo, you had a question.
Right there, how does that help overall? Like what scenario are we going to come across and like, oh, this is way better than just doing it to determine that?
If you are repeating the same SQL statement many times, like for example, select star from table, it's much better to do find all. You get promises by default, which is nice. And you'll get to learn how to wrangle promises a little bit better over time as well. Also, just scale. So right now we have two tables. And the use case of Sequelize, not absolutely clear maybe. But I have mentioned in the past, so many things that we teach you here, you have to drink the Kool-Aid on a little bit because they are useful at scale. They're useful at size. They're useful once your code is getting to the point where you're having trouble keeping it organized. This essentially allows for us to define many models in extremely prescribed ways and then relate them pretty easily without having to create the relationship columns ourselves. Like player belongs to team. We didn't have to think anything about defining player with a team ID, or even creating extra association methods. But then once you start creating class methods and instance methods and hooks, you'll see that things start to essentially get connected to their constructs a little bit more, and you get to reuse a lot more, which allows for you to grow and be flexible and keep things essentially intact. It also, in this case, allows now for our definition of how our information gets stored for our web app to happen within the web app. That's another big thing about Sequelize. We could write a whole bunch of SQL statements that create our tables in our web app in SQL, and like they will create the tables, and then like those tables will be created, and anytime we want to think about, oh, what's on those tables, we just go and reference those create statements. But now the definition and the usage of how we interact with that database comes from the same source. From inside that, and it's embedded in our web application. So we can like essentially have it on hand, as opposed to something that was created separately and then we have to like remember. If you were working on Twitter SQL and you had to recall what is the column name where we put the tweet text? Content, right. But where did you go? If you forgot that while you're working on that workshop, where did you go to figure that out? The schema? The schema wasn't actually in the code. You probably went to the seed file, right? So you went to a file filled with SQL statements. And by reading that file filled with SQL statements, which was like 40 lines or something like that for 2 tables and like very limited amount of data, that was your only definition of what your database looked like. Now we have a tool that allows for it to be defined through JavaScript in our program and constantly be interacted with. That, I think, is the biggest effect that you'll see over time.
Yes, and also when you're developing a product, you may be changing your mind on what you want to have as a data
Yeah.
model. You're doing SQL.
Yeah.
It would be a mess every time you decide to change.
Especially in alpha and beta development, you will probably be changing your mind about how data gets stored and then also be building new features in which you'll need new data over time. And you could have a SQL seed file with create table statements, or you can have JavaScript classes in your program that allows you to define this and change it over time and, for example, resync them fairly easily. So yes, absolutely correct. It's hard to say. You have to see the context for it. You have to see what this turns into when you start building something huge and much bigger. I can show you and link projects in the senior phase or things that I've built where I could just say, hey, take a look at this repo. And then you get to go to the DB models directory. And then just by looking at that DB models directory, you can look at the file names and understand all of the tables that are in my code base. I built a music application. You'll see songs.js, albums.js, artist.js, and you can go and click on those files and see the SQL definitions for what those tables look like. And it's all written in JavaScript. And because you know SQLize as well, you know how to interact with it. Or you're going to come to know SQLize over time. Yeah? The only time SQL from this point on is going to be useful to you is in 2 cases. One, when you're trying to debug SQLize. Let's say for some reason my create statement didn't work for some reason, or it's working unintentionally. We can go to the terminal and see what the SQL statement that .create created. And that's right here. The other scenario I would say is when you want to run a query from outside your program. Like I described like the marketing team asking me for like arbitrary queries sometimes. I would not be doing that through SQLize. I would be doing that through Postico and just like writing a select query or something. Yeah. So SQL is still useful. It's just not your main avenue anymore. And it never should be, really. This is much better once we get into building like serious apps. But once again, drink the Kool-Aid. It's a dark reference if you know what I'm talking about. Any other questions? OK, great. It's 5:58 on a Friday, so I mean, it's like we're done. I'm not going to send out any pairs or anything like that right now. We're just going to get started on this workshop next Monday. Yeah. I am going to send out some slides that you didn't see about SQLize. They're a little bit more theoretical, stuff about databases in general, ACID compliance and stuff like that. And I'll be sharing those in the library. And there's no need for you to like read them over the weekend unless you're very curious. But they'll be referenced for you during the workshop next Monday. Ryan, you have a question? Oh, hell yeah. Obviously, the audio is going to go down sometime in the middle when my mic went out. But it'll have audio for the rest of it. Any other questions? Cool. Good job this week. This was a big week. This is an introduction to a lot. The only thing you're missing right here that I think is absolutely core is React. So you learned a lot this week. Node, NExpress, NSQLize, and promises. We're going to be re-upping on all these things given time, and React is going to be a huge one as well. But this is a big week. Week 2 is really hard. So congratulations. Yeah. And party hard, dudes and ladies.